All right, everybody ready? So this is section 6.6, sorry. And we're going to talk about a triangle inequality theorem today. And the first part it says for 3 segments, that's what we're filling in, for 3 segments. To form a triangle, a special relationship must exist among their lengths. Okay? So in order for 3 segments to be able to join or to form a triangle, there has to be a special relationship between their lengths. All right? And what that says, or what that means is, I'm trying to see how I want to word this, sorry. Okay, I'm going to put 2 words in here. It's not really what we're supposed to fill in, but I think it'll help us out a little bit better. So the shortest just put the shortest. The shortest of the lengths of any 2 sides of a triangle must add to be larger than the length of the third side. Okay? So, 2 of the shortest lengths of a triangle must add to be larger than the third side in order to be able to form a triangle. Okay, so if I'm looking at these, my 3 pins, well, that doesn't really work there a little bit. Shorter, hold on. So let's say this one. Okay. So here's my 3 segments, okay? The shortest of these have to add up to be longer than the third piece in order to be able to make a triangle. So which 2 are my shorter ones? 2 markers, right? So if I add those together, is that going to be longer than my third side? Yes. So that means I could form a triangle. So you could do like this and form yourself a triangle, right? Everybody see that? Okay. Just use this as an example. All right. So here's my new third side, and here's my 2 sides. Okay? If I take my 2 shorter sides, they have to be longer than the third side. Are these 2 longer than the third side? Okay. There's no way I could make a triangle with this. No matter how wide I put these, this side is way too long, right? Okay, so that's what we're going to do. They're going to give you some lengths, and they're going to ask you if they can form a triangle. And the way that we do that is we always look at the 2 smallest sides. We add them together. They have to be larger than the third side. Not equal to, but larger than the third side. If the 2 smaller ones add up to be bigger than the third side, then yes, they can form a triangle. If they are not larger than that third side, then no, they do not form a triangle. Okay, so that's what we're looking at here. So these first few examples, it's asking me, is it possible to form a triangle with the given side lengths? If not, explain why. So if I'm looking at A, my 3 side lengths are 9, 12, and 18. What are the 2 smaller ones? 9 and 12. 9 and 12. Okay, so if I add 9 plus 12, what does that give me? That gives me 21, right? Okay. Is 21 larger than 18? So then, yes, those can form a triangle. Again, it can't be equal to. It has to be larger than in order to form a triangle. So try B, C, and D. Again, you're adding the 2 smallest numbers. Those 2 have to be larger than the third side in order to form a triangle. You don't really have to explain to me why or why not. You can just put yes or no. It has to be larger. And a lot of the times when you look at these sides, most of the time they're going to list them in order, small, medium, and large. However, sometimes they're going to mix them up. So just make sure you're adding together the 2 smaller sides. What do we think about B? Can those three form a triangle? No. Okay. 3 plus 5 is equal to 8, not greater than 8. So therefore, that cannot make a triangle. What about C? Yes, because 2 plus 5 is bigger than 6. And what about D? No. Okay. 3 plus 4 is 7. 7 is smaller than 8. It has to be larger than 8. So that's how we determine if the three numbers given can form a triangle. Add the two smaller ones together. If they are greater than the third, then yes, they can form a triangle. And then sometimes they're going to give us the lengths of two sides of a triangle. And we can figure out a range for that third side. It could be bigger than this or smaller than that. And that's what we're looking at. When I give you two side lengths of a triangle, I can find a range for the third side. So it says, if two sides of a triangle have a length of 4 and 8, what would be the range for the third side? Is everybody ready? Okay. To find the smallest value, what the smallest thing it could possibly be, we are going to subtract the two numbers. Okay, we're talking about the two numbers they gave us in this example. Okay, what do I get when I subtract those? I get 4, right? Always do the bigger minus the smaller. And then to find the largest of the value, what do you think you should do? Instead of subtract, you should probably add. Okay. And if I add 4 and 8, what do I get? 12. Okay. So that's the range of the third side. But here's how we're going to write it. We're going to write an inequality with the smallest number first. What's smaller, 4 or 12? 4. Okay, and I'm going to write it big right here because my thing that I had written is too small. Okay, the smallest number on the left, that goes first. Then what you're going to do is you're going to write a less than, and then you're going to write an X. Yeah, that was kind of small for me, so. And then we're going to write a less than again. Oh, it's got all that, so yeah, I'll put it there too. So we're going to write the smallest number on the left and the largest number on the right. Okay, and the largest number we said was 12. So we're going to ask for a range for that third side. Small number less than X, less than big number. Okay, that helps you to write it like that somewhere. Small less than X, less than big. And that's the way it always goes. Your smaller numbers are always on the left. So when I ask you for a range of values, you're going to subtract to find the smallest, you're going to add to find the largest, and then you're going to write your inequality like that. So far, so good? All right, so try A, B, and C then. Subtract, get your smallest, put it on the left, less than X, less than add to get the biggest. Subtract to get the smallest, less than X, less than add to get the biggest. And that will give us our range of values for the length of that third side. What would my smaller value be for A? 2. Okay, then we're going to write less than x, less than, what would my biggest number be? 16. I got 2 from subtracting. I got 16 from adding, and it's always less than x, less than. Small, less than x, less than big. Everybody okay with that? All right, what about b? What's my smallest one going to be? 22. And then less than x, less than 28. What that says is x is somewhere in between 22 and 28. That's what that inequality reads. And then for c, what's my small one? 18. Less than x is less than my big one would be 42. So the rows of that third side